Day 466 of doing a LeetCode problem every day. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2787, ways to express an integer as sum of powers. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given two positive integers n and x, return the number of ways n can be expressed as the sum of the x power of unique positive integers. In other words, the number of sets of unique integers n to 1 and 2 all the way up to nk, where n is equal to n1 to the x plus n2 to the x power plus all the way up to nk to the x power. Since the result can be very large, return it in a modulo 10 to the 9th power plus 7. For example, if n equals 160 and x equals 3, one way to express n is n equals 2 to the 3rd power plus 3 to the 3rd power plus 5 to the 3rd power. All right, y'all, so that may seem a little bit confusing at first. Let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, the first thing I want to do, since we see this, it says return it to module 10 to the 9th power plus 7. We could just handle that right away so we don't forget to include that in our solution. So we could say let mod equal 1 underscore 000 underscore 000 underscore 007. And we're just going to handle that now once again, just so we don't forget it when we're writing our solution later. Now, let's see what the examples say so we can make sure we're doing this right. So in example 1, we have our input n equals 10 and x equals 2. Our output is 1. It says, the explanation says we can express n as the following. N equals 3 to the 2nd power plus 1 to the 2nd power, which equals 10. It can be shown that it is the only way to express 10 as the sum of the 2nd power of unique integers. So let's break this down one step further. So we have x equals 2. That lets us know what our exponent needs to be, right? So as you can see, this was 3 to the 2nd. This was 1 to the 2nd. So and n equals 10. So we need to see what positive integers, or excuse me, what unique positive integers can we use or find the power of x, which is 2. So which unique positive integers to the power of 2 can we use so that when we add them together, they'll equal 10, right? So as you can see, 3 to the 2nd power, that's going to give us 9, right? So let's just say 3 to the 2nd equals 9. And then 1 to the 2nd, sorry, y'all, 1 to the 2nd equals 1, right? So 9 plus 1 is going to equal 10, which is what we want, right? So let me see, 9 plus 1 equals 10. Boom, so 9 plus 1 equals 10. That's what we want. We want to find something that equals n. In this case, n is 10. So we do 3 to the 2nd, right? That's going to get us, once again, that's going to get us, sorry, I don't know what's going on with my computer. That's going to get us 9. And then we do 1 to the 2nd, and that's going to get us 1. Then when we do 9 plus 1, that's going to equal 10. But we're not done yet because we're not returning the positive integers themselves. We're just returning how many ways that n can be expressed like that, right? So in this case, there's only one way that we can express that way, where we can find 2 integers to the 2nd power, or as many integers as needed to the 2nd power, so that when we add them together, it equals 10. So that's why we return 1, because there's only one way to achieve that. So let's take a look at example 2, where there's multiple ways to achieve n. So in the example 2, we have the input n equals 4. This time x equals 1. So once again, we're looking for positive integers to the 1st power. This time the output is 2. Explanation says we can express n in the following ways. N equals, so 4 to the 1st power, that's going to give us 4. So that equals n. Boom. and then 3 to the first power plus 1 to the first power, that's going to give us 4 as well. So that equals 4. These are the two ways, right? We can't do 2 to the first power plus 2 to the first power because it says right here we want unique positive integers. So 2 to the first plus 2 to the first, that's not unique integers because there are two 2's. But when we do it like this, all the numbers are unique, and these are our two ways of achieving n by doing numbers to the x, or the first power in this case, and there's two ways to do that, so we return 2. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Now we already handled the modular part of the solution. Now we need to build the list of powers containing all a to the x powers such that a to the x power is going to be less than or equal to n. Then we're going to compute each a to the x power using integer multiplication and stop when it exceeds n. So first we need to create our variable. We can declare, sorry y'all, that should be up here in the function. We can declare a variable called powers, and we'll just set that equal to an array of integers to start and put 2 parentheses to initialize it at the end. Then we're going to declare another variable called base, and we're going to set that equal to 1 to start. Now we need to increase base until base to the x is greater than n, or would overflow. So we're going to say while true, what we're going to do is we are going to open up the brackets, and then we are going to declare a variable called power with no s, and we're going to set that equal to 1. Then we're going to declare a variable called too big, and we're going to set that equal to false. Boom. Now we need to compute the base to the x power safely by repeated multiplication, and before each multiply, we're going to check if multiplying would exceed n or cause an overflow. So we're going to say for underscore n 0, sorry y'all, that should be 1n, 0 dot dot less than x. We're going to open up the brackets, and if power times base is greater than n, then we're going to mark it as too big. So we're going to say if power is greater than n divided by base, then we're going to open up the brackets, and we're going to say too big equals true. Come underneath that, and we're just going to break. Then we could come underneath this if statement, still inside the for loop. We're going to say power times equals break, just like that. Or sorry y'all, not break, base. Boom. Now if we exceed n for this base, then no longer base will work. So that means base is too big. So we could say, if we could come right here, and we could say if too big, or 2 vertical lines for or, power is greater than n, we're going to open up the brackets, and we're just going to break. Otherwise, we can record this power by coming underneath this, and we could say powers dot append, open up the parenthesis, power. Come underneath that, and we could say base plus equals 1, just like that. Now we're going to create a dynamic programming array, which is going to store the number of ways to make sum, which in this case will be s, using distinct powers. Then we're going to initialize that DP array with as 1, which is one way to make 0 or choose nothing. So we're going to come right here, and we're going to say var dp equals an array, open up the parentheses, repeating, colon 0, comma, count, colon, n plus 1. Boom. Then we come underneath that, and we say dp square bracket 0. We're going to set that equal to 1. Boom. Now we're not done yet, but we're getting there. So for each available power, we're going to update the DP in reverse, and reverse iteration ensures that each power is counted at most once. So we're going to say, come underneath this, we're going to say 4p(n) powers. We're going to open up the brackets. We're going to skip any weird out of range, right? So we're going to say if p is greater than n, then we can open up the brackets and we can just say continue. Boom. Then we need to iterate j from n down to p. So we can come right here and we're going to say 4j in stride, open up the parentheses from colon n comma through colon p comma by colon -1. We're going to come outside of the parentheses, open up the brackets, and we're going to say dp square bracket j, set that equal to, open up the parentheses, dp square bracket j, come outside the square bracket, but still inside the parentheses, plus dp square bracket j minus p, come outside the parentheses, and we're going to say mod. Boom. Then we just need to return the answers by coming right here, and we can say return dp square bracket n. That should be all she wrote, y'all. So let's go ahead and give it a run. Let's see, and it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 11 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, make sure you get one more look at the code. This is the top part. And this is the middle. And this is the rest of it, y'all. And with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.